This video will be covering the CLD Success Package exercises. My name is Mark Ramsdale. I'll be your host for this presentation. This video and the accompanying videos for the CLD Success Package will be covering the general themes for the CLD exam. We'll be tying back the lessons in each of the exercises to the general themes for the CLD exam. We'll be talking about file I/O, timing, application responsiveness, and we'll be looking at sequencer type applications that use different architectures such as polling, producer-consumer, state machine, and we'll look how these steps are processed, where the steps come from, maybe the model or possibly from the file I/O. Let's take a look at timing first. There are different methods used to create a timer. There are different requirements upon that timer. For example, is pause functionality required? Also, where are we going to code the timer? Is this going to be in a functional global variable, or are we going to integrate this timer directly in the main VIs? Let's take a look at some examples from the CLD Success Package. In exercise 1, the elapsed time express VI is used. It's important to know the features of this express VI if you're going to use it in the CLD exam. In exercise 2 and its challenge exercise, we're still using the elapsed time express VI. First in a functional global, 3 states, and secondly, adding a pause functionality in an application that uses the elapsed time express VI. This is similar to integrating into a larger application. In exercise 3, we use either the bit timer or the get time and date in seconds, and we use a functional global variable style solution. These sub-VIs would be used in the context of a larger main VI, a caller, which would pass to them time targets and or different functionality for these functional globals. In the main exercise, we have a pause and resume functionality. And in the challenge, we have a more simple and straightforward start and read, or reset the start, and elapsed time reading the amount of time that's gone on. These would be integrated into a solution for the CLD and be called by that main VI. When designing a functional global for your solution, you must consider how will this timer be used? When will it be called in the solution? Do you need to have some defensive programming in case a pause is called while already in pause, or a read is called while in pause? These are considerations that must be thought through before launching into developing the code. In exercise 4, we take a look at using the timeout case of an event structure for a timer. Here we see that it's used to measure periods of inactivity on the user interface. In the challenge exercise, we take a look at, can the timeout be used as an actual elapsed time timer? And we'll see that there are some downfalls to using this method. The decision to use the timeout case of an event structure relies heavily upon the model. If there are additional elapsed time requirements, the timeout case alone cannot support all of the timing requirements for an application. In exercise 9, we look at integrating a timer into an application. Here we have a step sequencer. The timer used is the elapsed time express VI. We see that there are 3 states that the step sequencer can go through. We see the interaction between the timer and the steps. Certainly the timer cannot be inside the step, otherwise the application would appear locked up for the duration of the elapsed time. In any application, the timer must be repeatedly accessed in order to increase and show the elapsed time and to take the measurement of the time has elapsed indicator flag. In this simple application, the timer can reside in the main VI loop. In a more complex solution, the timer might be in its own state, in which case not only the processing sequencer states, but also the timer states must be accessed repeatedly. We'll look at that in the next examples. We'll take a look at some of the ways the timer can be integrated into an application. In example 10, the stepping sequencer is a straightforward state machine. The timer is in the main loop, which means that it is accessed every iteration. The indicators can be updated, and also the inputs can be changed as needed. The next example is CLD number 13. The timer is in the main loop. It's integrated into the main VI, and the stepper, or the sequencer, does not have any time steps. It does use an event structure, but there's no timing involved. The timeout case is not used. Let's take a look at the encapsulated timer, which includes some business or model logic that have an effect or constraint or change to a basic timer. Here we see that there's a functional global variable with two states, start and read, and there is some change to the basic read that we've seen in our previous timer examples. In the next example, CLD number 12, we see that the timer is incorporated inside the steps. The architecture of this solution is an event-driven queued state machine. The timer itself is a functional global variable. It uses the get date time in seconds. The final example of timer integration is exercise number 14. We see that the timer is encapsulated in a functional global variable format, and it is used throughout the entire application in various locations. For example, the timer is used in an initialization outside of the main loop. Inside the main loop, the timer is accessed each iteration in order to read the time elapsed values. In addition, we see that the timer is used in several of the steps. For example, in the idle step inside the event structure, the timer is read to find out whether or not time has elapsed. In the case structure, we see that there is a pause and an unpause or resume step. Also, there are steps to change the time and to check the timer. In summary, we have reviewed these main points regarding timers. There are different methods used to construct a timer. The timer could be a functional global variable, or it could be integrated directly into your main VI. Sometimes the timeout case for an event structure is an effective tool for the timing requirements or to help or assist with the timing requirements. The timers themselves may or may not need to have a pause or potentially an idle state. More importantly, when creating the timer, consider how this will be integrated into your main application. Look at the model, the requirements that the model will have. Think about the architecture that you're going to use, then build the timer. We have reviewed a lot of detail regarding timing. Let's consider now the CLD exam. Once the specification has been read, you should develop your timing requirements. Consider what kind of a timing module you're going to use. Perhaps a functional global variable, perhaps the timing will be integrated directly into the main VI. In either case, be sure to create the timing module early and thoroughly test it. It would be very difficult to pass a CLD exam if the timing is not functioning correctly. A general recommendation is to have the main architecture running so that it can start and stop, then to create the timing, to make sure that the timing is working correctly, and then proceed on to some of the model logic, potentially first file input and output. I hope that this section on timing has given you some great pointers on how to approach the CLD exam and how to integrate different styles of timing into your solution.